So far, we have discussed how to create charge in an object and how to calculate the total amount of charge and excess of electrons in a charged object. Now, let's talk about the distribution of electric charge in the object. So, in a conductor, charge can be distributed in three ways. First is linear distribution. That means charge can be distributed over the length of a conductor. Okay, so this is called the linear distribution. In the linear distribution, the amount of charge per unit length is called the linear charge density or the line charge density. Linear charge density or the line charge density, which is symbolized as lambda and defined as total amount of charge divided by total length of the rod. If the rod has the total length L and total charge Q, then its line charge density will be Q by L. So its unit will be unit of charge divided by unit of length. So unit of charge is SI unit of electric charge is coulomb, and CGS unit of electric charge is stat coulomb, and 1 coulomb equals to 3 into 10 to the power 9 stat coulomb. Stat coulomb is also called ESU, electrostatic unit of charge. So here the unit of line charge density will be coulomb per meter, because length has the SI unit of meter. That means coulomb meter inverse. And you have to find the dimensional formula of line charge density as well, which is nothing but dimensional formula of charge divided by dimensional formula of length. Now we know that total current I equals to charge per unit time. That means Q equals to I into T. Now electric current and time both are the fundamental physical quantities. So the dimensional formula of electric charge is equal to I into T. That means T into I in the conventional form. Okay. So dimensional formula of line charge density will be dimensional formula of charge, which is Ti, and dimensional formula of length, which is L. That means the linear charge density has the dimensional formula of L inverse Ti. Okay. Now the second distribution is surface charge distribution. Surface distribution of charge, or the surface charge distribution. Okay, this is the first distribution and this is the second distribution. When the charge is distributed over the surface of a conductor, then the amount of charge is measured in terms of surface charge density. So we are going to define the surface charge density, which is symbolized as sigma, and this is nothing but total charge divided by area, surface area actually. So the amount of charge distributed per unit surface area of a conductor is called the surface charge density. So let's find its unit and dimension. The surface charge density has the unit of coulomb per meter square. That means coulomb meter to the power minus 2. And it has the dimensional formula as Ti divided by L square, because Ti is the dimensional formula of electric charge, which is just found. And the surface charge density has the dimensional formula as L to the power minus 2 Ti. This is very important. For a spherical conductor, the surface area, if it has the radius r, the surface area is 4 pi r square. Then we can write the surface charge density of a spherical conductor as q by 4 pi r square, which means the surface charge density is inversely proportional to the square of the radius of the conductor. Okay. And since the curvature is always same at every elementary portion of the sphere, and distance is also same, that means the every distance is equal to the radius of the sphere, then sigma is constant for a spherical conductor. So this can be a MCQ question, that which shaped conductor has the uniform surface charge density, and answer will be the spherical shaped conductor. Okay. And now the third distribution is volume distribution of charge. Volume distribution of charge, which is measured in terms of volume charge density. Volume charge density, which is symbolized as rho, and it is defined as total amount of charge per unit volume. Okay, and obviously this type of charge distribution is possible only for the three-dimensional object like a sphere or a cylinder, solid sphere respectively. And let us consider a solid sphere of radius r. Then it has the total volume 4 by 3 pi r cube. Then the volume charge density for this solid sphere will be q by 4 by 3 pi r cube. So volume charge density rho is inversely proportional to the cube of the radius of the spherical conductor. And let's find the unit and dimension of volume charge density as well. And it is given by coulomb per meter cube. And the dimensional formula of volume charge density is Ti for electric charge and L cube for the volume. That means we are getting L to the power minus 3 Ti. So this is the three types of charge distributions and their units and dimensions and formula. So this is all from this video. In the next video, we will discuss electric field intensity, Coulomb's law, electric field lines, Gauss's law, electric flux, etc. If you find this video useful, please like it and subscribe this channel to get more videos. Thank you.